All right, so today we're going to talk about molecular compounds, which are different from ionic compounds. So we have been talking about naming ionic compounds, but now we're going to add molecular compounds to that. This is going to be chapter 9.3 in your book, and you should not only be using these lectures, you should still be reading your book and taking notes on that, so that you have multiple avenues that you're learning this information from. But yes, this should be also a shorter lecture compared to the ionic compounds one. So let's get to it. Okay, so binary molecular compounds. Okay, binary still means that there's only going to be two elements in them. Now, for our ionic compounds, if you recall, we had metals and nonmetals in them. However, molecular compounds or covalent bonding compounds is only going to be nonmetal elements. Okay, so in the previous lectures, I keep talking about the staircase. I finally decided to go find a good image of it. All right, so this imaginary staircase here, and any periodic table you see, regardless of the colors, you can kind of see this staircase. Okay, nonmetals are to the right, and metals are to the left. Now, some of these, like in this area right here, like right along the bottom part of that staircase, they're called metalloids, and sometimes they act as nonmetals or as metals. So you might see a few of these in these molecular compound ones, but it's generally pretty clear how you're going to name these things. Okay, but if you ever have any questions about that, just let me know. But as you will see by the way things are named, you'll know whether it's a molecular compound or an ionic compound. Excuse me. Okay, so for molecular compounds, okay, when you identify a compound that has only nonmetals, you're going to have to switch your mind into prefix mode. Now, what I mean by prefix mode is you're going to see prefixes in front of these elements, which in some ways makes things easier as long as you can mentally switch to be thinking in prefix mode. So the reason why we use prefixes for molecular compounds is because nonmetals can combine in different ratios. And so we used prefixes to say exactly how many atoms of each element combine together. All right. A very well-known example is there's carbon monoxide and there's carbon dioxide, right? Like carbon and oxygen, they can combine in different ratios. And of course, CO3 is carbonate, right? So because there are so many different ways that these nonmetals can combine, we just use prefixes to make things easier because it'll tell us exactly how much of each element there is. So for CO2, it's carbon dioxide, and di is a prefix, goes in front of the oxide, and it means two. Okay, so we're going to have to learn these prefixes, but most of these prefixes are stuff that should be familiar to you from various things that you've learned throughout your life. Okay, so these are the prefixes you're going to have to memorize. So I'll go through them really quickly. Reminder, like you have this chart. I haven't posted these slides yet, but I will as soon as we're done talking. So you can use this to learn it. Okay, mono, easy, one. All right, we all know mono means one. Okay, di is two. The only tricky thing here is to remember that in chemistry, the prefix we're using is di, not bi, like you would see, bi in a lot of other areas, whether it be humanities or math or whatever. 3 is triangle. Okay. 4 is probably the trickiest one, tetra. Okay. You might like naturally think it's going to be quad or something like that, but 4 is tetra as a prefix. 5 is penta, pentagons. 6 is hexa, hexagons. 8 is octa, octagons. Okay, so really tetra is the only kind of tricky prefix, but you just kind of got to memorize all these different prefixes. Okay, questions about that? Okay, so once you know the prefixes, and as long as you have the prefix charts, writing molecular compounds is very simple. Writing their names. Oops, wrong title, sorry. First element. Okay, so the first element is going to get the normal name, of the element, and the second is going to get its IDE name like we did with the ions before. All right. So like I said, we are learning a different set of rules, for these nonmetals. You're used to, with ionic compounds, nonmetals always having that IDE ending, but in molecular compounds, the first one is going to get its normal name, and the second is going to get its IDE name. Okay. So for example, CCl4 is going to be carbon. I give carbon its normal name, and then tetra prefix chloride. All right. Why is it tetrachloride? Because there's 4 chlorides here. Okay. NO2 is nitrogen dioxide. Okay. 2 O's, which means 2 oxygens, dioxide. N2O4 is dinitrogen, 2 nitrogens, tetra, 4 oxide, oxygens. Okay. So you see how, like with the prefixes, in some ways it just makes things easier because it just tells you, like, you're just saying exactly how many of each thing there is. It's not like with ionic compounds where you have to do any crisscross nonsense or like figuring out how to balance it or whatever. You know exactly the number of each that you're supposed to get. Okay. Notice that for carbon and nitrogen, I didn't put monocarbon or mononitrogen. Okay. Generally, if you don't see the mono, it's understood that it's one, especially if it's the first element. However, if you put monocarbon tetrachloride, it's not technically wrong. It's almost like, being a little bit too formal, like with a name, like, me calling you Mr. whatever your name is, or Ms. whatever your name is, right? Like, it's just monocarbon tetrachloride would be like a little extra formal. If you have it, it's fine. If you drop it, it's fine. Okay. When the element is the second one, though, like carbon monoxide, generally they add the mono, or we add the mono prefix. I don't know why. It's just the way things are. Okay. Any questions about this naming stuff here? Oh, one more. Diphosphorus pentachloride. Same thing. P is phosphorus, 2 of them, diphosphorus. Cl is chloride, 5 of them, pentachloride. Okay. All right. So when we're writing the formulas, it's really straightforward. If I give you the name to write the formula, you just use the prefixes and go in order of the naming. If there's no prefix, that means it's mono, 1. All right. So here's some examples. Nitrogen dioxide. Okay. 1 N, 2 O's. Nitrogen dioxide. Boom. Done. Carbon monoxide. 1 C, 1 O. Okay. Straightforward again. Disulfur dichloride. Okay. 2 S's, 2 chlorines. Okay. Dichlorine heptoxide. 2 Cl's, 7 O's. Okay. So when you're writing the compound formulas, you just, the name tells you exactly how many of each thing there is. All right. So all you got to do is put those numbers, you take the prefix, translate it to the number in your head, or use the chart if you haven't memorized it, and then put it in there. Okay. And so that is writing molecular compounds. That's the whole thing. So the trickiest thing, like I said, is remembering to categorize in your head, is this a molecular compound or is it an ionic compound? But once you figured that out, if it's molecular, you're just going to use these prefixes and it should be pretty straightforward. Okay, so that's it for this lecture.